Okay, recording's going. Got the chat box open just in case anyone's got any chatting to do. You want to do anything particularly cool over the 4 day weekend? I didn't. I took it pretty easy. Played some video games. You know, spent half the weekend by myself because my wife was gone to a funeral. My daughter and her husband were gone to see his family in Branson, and so I got to kind of chill out by myself, some get some rest, get a few chores done, work on some projects. But all right, we had a short program last week that was due. We wrote a small math program. Now we're writing a larger math program. We're going to get more complicated math this week. So that's why I did the little easy one last week where you're just supposed to add two integers together, right? Just two integers, add them, print the results. And it was input statements. So they would enter an integer, the user of the program would. So this week it gets a little bit more interesting. So we're going to pull that up and take a look at it and get going on that. Let's go to our grade screen as usual. So looking down, last week we had the getting numeric input and the special assignment, which was just, like I said, a very short program. Didn't even require any pseudocode. This week we'll have pseudocode. Going forward we will, but I gave a break on the pseudocode on this special assignment. And it was just having the user input two integers through input statements, and then you added them together. And I saw some clever programs. I haven't got them all graded yet, but I've looked at some of them. Some of them are pretty clever where some of you put a little scenario into it. Rather than just enter a number, you made it a little story or why they're entering some number. That's great. That's great. I love it. You're using your imagination and creativity to make better programs than just enter a number. Enter a number is fine too. That's all that was really required. But this week on the math module, we're going to get into like exponential math and stuff with exponents. So let's take a look at that lesson before we take a look at the template for this week's program. The math module lesson 2.03. Math made easy. What's better than a snuggly new puppy? Oh, that's easy. A pre-trained puppy. Oh yeah, wouldn't that be much better? Potty train. You don't have to teach them to sit, roll over, not eat your shoes, all that stuff. Someone else already done. If only life were that easy. But guess what? Python is that easy because it's time to explore what this programming language has to offer. Okay, it's a little more advanced than rolling over too. So we're going to learn how to use the math module to identify useful black box functions. That means functions are already built in that we don't have to create to increase productivity. Identify the types of operations that can be performed with numeric data types and math expressions. Research functions related to Python using different sources to use for creating programs. And use the power and square root functions to answer mathematical problems and write a program. In case you haven't already guessed, Python has a library of built-in functions that make your programming work easier. These are sometimes called black box functions because the code is hidden. You don't see the whole code, but like print, string, integer, float. There's a reason they do what they do. It's a black box function. It's something that's already built in. So other programmers wrote these functions into Python. So Python already knows what to do when you use that. Just simply pick a function to include in your code, and Python does all the work in secret. That way, you're totally impressed, and Python feels really special. So to set the record straight, Python is not performing magic tricks. It's just doing the hard stuff, so you don't have to think about it. So something useful in Python is its math module. It's a collection of pre-built math functions that prevents you from having to math the problems out yourself. So let's say you want to find the square root of something. Can you do that in your head? Depends. Is it a perfect square root? Like if it's 25, we can do that. But if it's 23, no, we can't do that. Do you want to do it on paper? No, we really don't want to have to do it on paper. So here's the good news. Python can do it with one of the functions. To use these functions, we have to tell the computer where to find them. So we have a new statement that we're going to start our program with. Before we define main function, we're going to put from math import with a star, little asterisk. to tell it, hey, I'm going to use those math functions in this program, so be sure and go access those. So the Python math module has tons of math functions available. So we've provided something for you, the Python API, right up here at the top. They have a link to it here, but it's always available in our menu bar. If you click on that, this will open up a whole bunch of pre-built functions. Got to make this bigger here so we can kind of get a better look at it. And we can click on the math module right here and go jump down to the math module. So it has this function here, ABS, that returns the absolute value. COS is the cosine, so it's got cosine built in here. Power returns the value of a number raised to a specific power. And we're going to look at that one today more in depth. Radians, sine, square root, we're going to look at that one closer too. And then there's the random module, where you can get a random integer. So there's all kinds of different built-in stuff. And we're going to get into turtle graphics before the semester ends here. We'll get into that real soon. But the Python API. So let's take a look and get familiar with some of the different functions. While there are many more you can use for a variety of mathematical processes, we're going to start with some of the basics. So using the Python math module, which function do you think would be more useful in solving the following? Finding the square root of x. Well, we saw in that API, there was a square root function, right? Square root. It comes with parentheses, so we put whatever x is in the parentheses, and it'll automatically calculate the square root for us. Raising x to the power of y. We'd use that power function for that, and we'll look exactly how to do that. Okay, using power and square root. Once you've imported the math module from math import, you'll have access to all the functions it provides. So all you got to do is call the function you want to use and then provide any required arguments. With whatever value you have to put in those parentheses. Those are the values needed to make the function work. So two of the most common are power and square root. So let's see how they look. Oh, here's power. Here's Gaming Forever. That's a great username. You guys, I finally found the magic axe of Kardashian. Time to level up like a boss. Actually, I'm trying to figure out how fast I can do that. I need to get 5,000 experience points before I can upgrade my magic axe to the superior sword. Well, you know what? Quit judging me. It looks good with my armor, right? You know, because that's all the kind of chat you see in these online random games that people play. Okay, we're going to help get this gamer figure things out by using Python, although we think his armor looks just fine as it is. The magic axe of Kardashian lets you gain levels exponentially faster. So instead of just gaining levels by getting points, it lets you exponentially gain points. So Gaming Forever gains 100 experience points per battle, but with the magic axe, he gains 100 to the power of 1.2 experience points per battle. We want to know how many battles it takes to reach 5,000 experience points. So Python's got this simple function. So let's roll over the parts of the code to see how it works. Power, that's the power function that tells Python, raise the first number by the value of the second number. So in the parentheses, the first argument is the number that you want to raise, right? I'm doing 100 to the power of, and then the second one is the exponent, the second argument. So 100 to the power of 1.2. That's a simple, all you have to do to raise 100 to the power of 1.2 with the power function. Square root, looks like our gamer buddy's running through another snag. Let's see what this says. Hey, everybody, turns out I can't level up in time. And Play One says, what? Why not? I've got finals coming up and like 3 papers to write. I literally have tonight to figure out this problem, ASAP, or I'll never get to play this game again. Well, that's a little dramatic, maybe, right? Basically, I need the square root of 3. It's like, dude, just use the math module. So let's use Python to save the day once again. So print. So we're wanting to print the answer out. The square root, and we see 3. Whatever we put in parentheses, it'll calculate the square root of. So say, hey, there you go. We'll never see how the Python performs in math functions because the functions live in the black box. And Python doesn't want to bother you with little details. It'll just go get the square root of 3 and print it for you. Think of it like buttons on a calculator. You don't have to know how the calculator calculates its answers. All you want to do is press a button and get the answer. So that's what we've got there. All right, let's look at the next page. Oh, we have a programming spotlight. Donald Knuth, 1938. Apparently is still alive, at least at the time that they put this curriculum together. Most likely to grow plants with square roots. I like it. All right. He is the author of The Art of Computer Programming. So this programmer, he's also a math enthusiast, as a lot of programmers are, has a soft spot for numbers and writing super complex mathematical algorithms. He is dubbed the father of the analysis algorithm. This guy can run math loops around you and crack jokes while doing it. So Donald Knuth. Who knew numbers could be so much fun, especially when you write a program to crunch the numbers for you, right? So by learning and utilizing the functions in Python's math module, plus all the other built-in functions, you can create some pretty awesome programs. Most of the work's been done. So let's look at our Python guided activity. They have these just about every lesson where we can see how to use these functions in our program, because we're going to need to do some this week, some of these high-level math functions. So, like we said, before you define your main function, you're going to have to do this from math import asterisk, telling Python, I'm going to use those built-in math functions, so please open that box. So they got the comments, math import, define main. Now let's see what the code says. Num, so they've created a variable. This is just a name they chose for their variable called num, and it's going to assign a variable value of 4. And then they have exp. So this must be their exponent. So they've named it exp, and they're assigning a value of 2. And then p, that's kind of a boring variable name. They could probably do a better one. They're using the math function power, and they're taking 4 and taking it to the second power. So they're squaring it, 4 squared, right? 4 to the second power. So they're going to print. Now, this is where you have to use that string, right? Because if you're going to print numbers and letters in the same print statement, you got to tell it, hey, I know it's a number, but act like it's a letter. Just treat it like a string. So they're printing the number to the power of the exponent is, and whatever they calculate that to be. So let's run the program. 4 to the power of 2 is 16. That's correct, because 4 squared is 4 times 4, and 4 times 4 is 16. Now notice it gave it as a float value because we didn't tell it it had to be an integer. We didn't say it has to be, and it may not be an integer. So it's going to default to, all right, I did a calculation. I'll just default to a float value, which is okay. So by calling a simple function like POW and passing it 2 numeric values, Python's going to return the results. We don't have to tell it how to do it. Hey, if it's squared, that means you multiply it by itself. Python knows that. Someone else wrote that, so we're going to use it. Let's look at the next slide. Okay, read the code, predict the output, run it. Let's see. Again, math module, importing our math functions, defining our main function. We have the same numbers, 4 and 2. We're doing the same, raising 4 squared, but then we're also taking the square root of the original number. So 4. So we have the same print statement here, but we have a new print statement. The square root of this number is what we calculate to be the square root. And that's the end of the program, the end of the main function. All right, let's run that. Run. 4 to the power of 2 is 16. The square root of 4 is 2. Well, technically we know it's 2 or negative 2, but we're just going with the positive value in this one. So you can find the square root of a number just as easily. All right, let's look at the third. Oh, wait a minute. It did want us to do something. Explore by changing the value of number. And what happens if you assign a float value to number? Well, let's see. Let's change the value of the number. Let's say number is now 9. Let's run that program. 9 to the power of 2 is 81. The square root of 9 is 3. But what if we give it a float number? Like, how about 11.6? Let's find out what 11.6 squared is, or the square root of 11.6. We didn't tell it was an integer or a float. Let's see what it does when we don't define it. It just treats it as a float. 11.6 to the power of 2 or 11.6 squared, is 134.56. The square root of 11.6 is 3.405887727319. And it finally cuts it off at, looks like 11 decimal points. It goes 11 decimal points. And I'm sure it rounded it then. So we can do any numbers. If we're going to take it to the fourth power, how about that? To the fourth power is 18,106. We can do it to whatever power we want to. Okay, read the code, predict the output, select run program. Define main. Number is 4.0. Exponents 2. We're doing the square root of 4.0. We're doing the same thing here. So basically, it's the exact same as our earlier program, except we put 4.0 instead of 4. Run. Now it has a problem. Interesting. What it said, it says square root is not defined in line 10. S equals square root number. What did we do wrong? I see what we did wrong. Anyone else spot that? There's a hashtag in front of the math import. That means it's a comment, and Python never looked at that statement. So it did not know we were using the black box math functions. It thought we were just writing a regular program, and it got to square root, and it said, I don't know how to do square root, because we never told it to go open up the math functions. So if we take away this hashtag, now it's not a comment, and Python will look at this line. It ignored this line earlier. Now run the program. Now there's no problem at all. The from math import statement tells Python you want to use some functions of the math module. So we didn't call that. Fix the error by removing the hashtag. Sneaky, sneaky. Let's look at their last samples. All right, we're going to do this again. Modify the program to calculate the distance between X and Y. Ooh, okay. So they give us an X, which is at 4, and a Y, which is at 3. And the distance formula in mathematics, distance equals the square root of X squared, the square root of X squared plus Y squared. So this is all together. The square root of, and all of this is together. X squared plus Y squared. So distance, we've got to write the formula for that. So it is the square root of, so first thing we want is the square root function. All right, and then whatever we put inside there is what it's going to take the square root of. It's going to take the square root of X squared plus Y squared. So we want to do the power X squared, right? Because it'll take whatever number we have in the variable X, and this will say raise it to the second power, plus, let's put some space in there just to make it easier to read. Y squared. So we're taking the square root of everything in the parentheses, and what's in parentheses is X squared plus Y squared, using those power functions. We're telling it to go to the power functions. So it's going to take 4 and square it, and 3 and square it, add them together, and then take the square root of that, which should be 5. Yeah, the distance is 5. You're making math happen. By adding the power and square root functions together in the same line, we can calculate just about anything, right? That was the distance formula in mathematics. Very nice. So if you struggle when you're writing your program on how to do this, come back to these sample programs. Go back to the earlier pages of the lesson that tells you how to use the power function, how to use the square root function, whatever you're needing to do to accomplish our program this week. So let's take a look. All right, I'm going to pull it up. I've got it in Google Classroom already. They have a template here, but I've already got one built for you in Google Classroom. So let's see. I think it's this one, the math module, template 2.03. Let's look at it. Oh, it's got to load this in. All right. Let's look at what's required. Create a word problem. A word problem. So that means you're going to type out a scenario. Bob is wanting to calculate the volume and surface area of his basketball. Whatever you choose, you're writing a word problem. You're going to calculate, so it involves calculating the volume and surface area of some three-dimensional object. So the object you're going to choose can either be a cube, right? Some kind of square box type thing, a sphere, like a ball, something like a sphere, a globe, a cylinder. Maybe you got your Monster energy drink. You're trying to figure out the volume and surface area, or a cone shape. So that's the 4 different shapes you can use. And here are the formulas, because you don't have to go look up the formulas. You don't have to know the formulas. I'm giving you the formulas for volume and surface area for each of these shapes. So if you're doing a cube, the volume is the surface side, whatever the side is, whatever the length of one side, because a cube, every side is the same length. The length, the width, and the height are all exactly the same with a cube. So you just have to take the side to the third power using the power function. To calculate the surface area, you do 6 times the side squared. So you only have to use the power function. You don't have to use the square root function. The only time you use the square root function is if you decide to use a cone, because that has a square root in the surface area calculation. So depending on what you choose, a cube, a sphere, a cylinder, or a cone, that depends on which of these calculations you're going to do using the math module. So be sure you import the math function. So here it is. Print the description of the word problem for the user to read. So you're going to print, Bob is trying to figure out the volume of air that in the surface area of his basketball or his bowling ball or whatever it is, his beach ball, or a cube or a cylinder, a cone, whatever. And then you're going to ask the user to enter information necessary. So, okay, if it's the sphere, if it's a basketball, what is the radius of the basketball? Or maybe if you get fancy, you're going to ask what's the diameter, and then you divide it by 2 to get the radius, whatever. But you're going to ask them to enter. It's like on the sphere, the only thing you need to know is the radius, because it's 4 times pi, 4/3 times pi, radius squared, radius to the third. So in that case, you would just ask the user, what is the radius of your sphere? Or if you're doing a cube, what is the length of the side of your cube? Because that's the only thing you need there. If it's a cylinder, you need to know the radius and the height. H is the height. I guess I'll put that on there just so we have that. H equal height. And if you're doing a cone, you also need the radius and the height. So that's what the user would have to enter, because that's going to be part of your program, having an input statement where the user enters the radius or the radius and height. If you have pi in your calculation, some of these use pi, a lot of these use pi, just use 3.14. So we'll just round it off to 3.14. Then you are to print the results of each calculation. So that pops up, it says, what is your radius of your basketball? They would type in a radius. And then it would print out the volume of your basketball is boom. The surface area of your basketball is boom, right? So you would do the calculations, print that. So write the pseudocode. So right here, you're going to write the pseudocode. You're going to say whatever your story is going to be. I'm going to ask about the radius of a ball, and I'm going to have a story about Bob and his basketball or whatever. And then put your calculations. So I'll do I'll do the volume, which is 4/3 pi r to the third, and I'll do surface area, which is 4 times pi times r squared. And then I'll print those values at the bottom. So pseudocode doesn't have to be real long. Just tell what you're going to do. Then go to Python idle. Make sure you have your heading with your name, date, and description. Make sure you indent things properly. Use white space. That's where you can spread things out just to make it look better. And then make sure you use meaningful names. So here's an example of what someone else did. Jim's writing a report about planets. Sphere. For fun facts, he wants to calculate the volume and surface area for a planet. He needs your help by providing the name of a planet and its radius. So this time he went ahead and had him tell me what name of planet. Earth. What's the radius? So they entered 6,371. He probably asked kilometers. If I did this, I would say, what is the radius in miles or what is the radius in kilometers? Be specific on what you're asking because they may enter something different. And it says the planet Earth with radius of this has surface area of this many kilometers, this many millions, and the volume is this. Here's where you're going to put a copy of your code. I'm not even putting no screenshots anymore because that's just assumed, no screenshots. And so to copy your code, and there's the 4 questions for our post-mortem review. So that's what we got, guys. A program using your choice. You don't have to do all of these. Just pick one: cube, sphere, cylinder, or cone. There are the equations that you would use depending on which one you do. But you're going to put your own little word problem out there. So have fun with that. You're going to be creative. You get to decide what the word problem is now instead of all them ones in math that they give you. And you're like, okay, what's this word problem saying? What am I supposed to calculate? Now, see, you're the one that gets to create that whole thing now. But you're going to write that in there, have the inputs to where the user is going to input the radius or height or whatever they need to enter for whatever your scenario is. And then Python's going to do the calculations and tell them their volume and surface area. So you got any problems with this? Let's see. This is not an 8A. For B-Day. So if you have any problems with this, you'll have to email me this week. And if I get some time, we can set up a meet together if we need to. But otherwise, if you email me your code and say, I'm trying to do this and I'm getting the wrong answers, I'm happy to help you with your program. If you're getting errors, I'm happy to help you figure out your errors. So you can email that to me and I'm happy to help you. But, get started on this, write your pseudocode, so you got your plan on what you're going to do. Open up your Python idle, see how it goes. So this one is 100 point. Last week was just a 50 point. It was just a little simple thing with no pseudocode. This one is 100 point. All the ones for it, I think, are 100 point. So, all right, guys, you've got your assignment. We're getting into the fun stuff because we're using math. Okay, maybe that's just my opinion, but that's all right. But yeah, if you have any trouble with any of this, if you're working with one of these formulas, you're trying to do a cylinder and it's 2 pi r squared plus 2 pi r h, and you're having trouble figuring out how to write that, email me. I'll help you. Email me your program and I'll say, oh, here's what you need on that line. So, all right, guys, have a great week. I won't see you again until Monday now, since we only have one asynchronous day on Friday, and the B guys get that. So, have a good week. Have fun with this program. Make up something creative for your story. Have some fun with it. And we'll see you next time.